Hello everyone, April 26th, another late night LeetCode. Today I spent a majority of the day preparing for my committee meeting. I have a committee meeting coming in 2 days. Yes, this Wednesday. I have a committee meeting for my dissertation. So I am preparing my presentation deck, which initially I was kind of worried of how I'm going to approach it, but as I was doing it, I decided to go with a more humorous route. I mean, not sure how my committee meeting, how my committee members how do they like the presentation to be? Are they more, on the joking side, or are they more on the serious side? My advisor is very much on the joking side, so I decided to do a more funny one, a bit lighter in tone, and then have a lot of hidden punchlines that I am not gonna say, but just gonna be laying there. And if they identify it, they see it, and they start laughing, then that's definitely what I want. If they don't see it, it's also fine. But the whole thing is interesting, because every time I just try to see if I can find any way to slide a joke in. Most of the time, no, but sometimes I was successful. I mean, I don't know if it's gonna be successful, but I think it's funny. Anyway, let's take a look what we have today. Furthest building we can reach. It's one of those questions, huh? One of those building questions. How much rainwater you can collect, what's the city line, something like that. I've definitely done a lot of those, but I'm not sure if I can still handle this in the first try. All right, you're given an integer array, heights, okay? Height of buildings, some bricks, and some ladders. What? Bricks and ladders? Oh, wow. And this animation is fun. You start a journey from building 0 and move to the next building by possibly using bricks or ladders. While moving from building I to building I plus 1, if the current building's height is greater than or equal to the next building's height, you do not need it. Yeah, you just jump, right? Just jump. You jump. If the current building's height is less than the next building in height, you can either use one ladder or bricks. Return the furthest building you can reach if you use the given ladders and bricks optimally. So I can use ladder once. Starting at building 0, you can follow the go to building 1. You can just fall. Building 2, use 5 bricks. You must use either bricks or ladder because yes. Go to building 3. Without using ladders, you can go to 4. Building 4, using a ladder, you must be either bricks, yeah, and then you end up at building 5. It is impossible to go beyond building 1, 2, 3, 4 because you don't have any more bricks or ladder. Wait, I can go to 1, 2, wait, 0 index to 1, 2, 3, 4. I can now keep going. All right, we have bricks and ladders. This seems to be a fun question. So if we have lower, we definitely go. If we have higher, then we need to determine whether to go or not to go. Well, the goal is always to go, right? I mean, if you have a building that's higher than you and you decide not to go while you still have the resource, and then you lose the game, right? Because the goal is to go as far as you can. That is the goal. So in order to go as far as you can, I think it is imperative that whenever you have a chance to go, you shall go. Sorry. Shit. I'm trying to get my pencil ready, but this pencil just sucks. It sucks big time. Yeah, these golf pencils, they just suck big times. God, this is terrible. I have to keep doing this. Anyway, so if we have a building that's higher than me, and I definitely want to go, right? Because if I don't go, then there's no chance of succeed at all, right? So we go. Now just a question of which one to use. I mean, if the difference is bigger than the number of bricks I have, then the only way I can go is through the ladder, right? But if the height difference is smaller than the number of bricks you have, then you have two choices. You either use the ladder or you use the brick. I mean, you should use the brick, right? If possible, always use the brick, because ladder is more valuable. You don't want to use the ladder when the brick can work, so you never know. Yeah, I think that's the idea, because you never know. Man, this pencil just sucks. How could you suck so bad? Oh my god, I'll be back. That pencil sucks. Never had a pencil this bad. Unbelievable. Unbelievable. If you go with that route, wouldn't that breathe? There's a hole. Come on, just work. Come on, pencil, just work. How hard is it? Goodness. You suck. Something is wrong with this pencil sharpener. I can't seem to get it to work. Come on, pencil sharpener. Come on. Oh wow. This is the worst I've ever had. It just doesn't work. Whatever I do, it does not work. It could be the wood, it could be the pencil sharpener. I feel like something is wrong with it. I need to buy a better pencil sharpener. This one's not working. It's not stuck. How do I unstuck it? usable? Jesus, it's not usable. Broke again. My dear God. This is so bad. Alright, I want a new pencil sharpener. Like a legit new one. A good one. A one that I can really use. Not something like this. Completely useless. Unbelievable. Can't believe it. I'm wasting time doing this. I got it to work. Don't ask me how. This wasted a lot of time. Wasted a lot of pencil. When I started, it's a long pencil. When I end, it's a short pencil. Jeez, unbelievable. All right, I'm back. Oh man, it took me like what, 10 minutes just to get a pencil ready. All right, back to the question. So I was thinking, if we have a building, so it's only like what, two main situations, right? The first situation is when the next building is lower than you, then you definitely go, no question. Second situation is the next building is higher than you. Now, when the building is higher than you, you have two choices. You either go or you don't go. But if you have bricks or ladders left, you definitely want to go. Why would you not go, especially if you have ladders? You always go. So we go, right? Without a doubt, we go. And then we have a question whether to use bricks or whether to use ladders. Now, ladder is more valuable, right? Ladder is more valuable. So the idea is to use the brick as much as we can, right? We need to use the brick as much as we can, like the perfect amount of brick, but don't waste brick, right? If we can, just don't waste brick. Because I can see a situation where at the beginning, say we have 5 bricks, right? And the first gap takes 4. And then the second gap takes 2. And the third gap takes 3. Now, the ideal will be use the ladder first, and then use the brick for 2, then use the brick for 3. So you can go all 3 times. But if we use the ladder, if we use the brick in the first one, and then we use the ladder on the second one, and then we have 1 brick left where we cannot go anymore. So that is the thing that we have to consider. Now we want to go as far as possible, right? As far as possible. That means, can we think about this question as a DP question? Like, you at a certain building, and you have certain number of bricks and a certain number of ladders remaining, and the question is how far you can go from that point onward. So isn't that like if every time gonna go, and then we can bifurcate, right? So you either take bricks or you take ladders. What's the brick and ladder look like? Yeah, it's not possible just to always bifurcate. Can we like, do some analysis on this? Because we know all the building heights. That's something we do know, right? Let's take a look at this one, right? So we have 4, 12, 2, 7, 3, 13. Now 13 is 18, 20, 3, 19. So difference between will be minus 8, no, it will be 8, minus 10, 5, minus 4, 15, 2, 17, minus 17, and last one is 16, right? So we're going to start with 10 bricks and 2 ladders. So we had the first one, we had 8. Now we don't know, we can use 8 bricks or we can use 1 ladder. So we bifurcate. It's going to keep bifurcating if you have a lot of bricks. That doesn't sound right to me. Anyway, or we go the other way around. Like we have 10 bricks and 2 ladders. We have in total height, star length ladders, and 0 to 10 to the 9th bricks. Alright, so we can create all combinations of bricks and ladders. So like say we have two rows, right? So we have 2 rows, 1 ladder, 2 ladder, right? And we have 10 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the total number of states that we can be in. Right? The total number of states we can be in terms of bricks and ladders. And then we're going to try to find the maximum we can go, because at the start it's 10 ladders, 10 bricks and 2 ladders, right? This is the start. Oh, shouldn't we have another layer? So what I'm trying to think about is, for each position, we know how far we can go, right? For each position, we know how far we can go from a certain position. For example, from 3, right? From 3, we know, from 19, we know it's 0, 1, 2, 3, 4, 5, 6, 7, 8. The 19 is 8, right? Because it can only go to itself. From 3 is 7, because 3 to 19 is 16. We cannot use anything. Which means if you reach 3, then the furthest you can reach is 7 under all situations. Now, at 20, the furthest you can reach, from 20 you can reach 3 without cost. So from 20, the furthest you can reach is also 7. From 18, now you have different situations, right? From 18 depends on the number of ladders, right? If you have no ladder and no brick, so if we have 0 ladder, right, and smaller than 2 bricks. So if it's 0 ladder, smaller than 2 bricks, then you can go to 6. If you have which means anything more than these, you have 1 ladder larger equal to 1 ladder, or larger equal to 2 bricks, then the maximum you can go to the next one, which say you can go to 7. Now let's move to 3. From 3, we have 15. Now 15 is larger than the number of bricks, so we cannot use bricks. But if you have ladder, which means if you have larger or equal to, if you have no ladder, if you have 0 ladder, then the maximum you can go is 5. If you have larger to 1 ladder, you can go to 7, which you can go next one, 7, right? Now, 7, we don't have to do anything, which means at 7, you just go to 7. Well, yeah, at 7, you just go to the next one. Go to the next one. Well, it depends on. Hmm. Well, it depends on actually the situation. We have to extend the concept. Like the maximum, I don't think it works. So, like if I know, like I'm at 4, right? I want to know how far I can go. Then I look at 12, say how far I can go at 12, and then I have different bunch of like combinations, right? And then I say from 4 to 12, I have 2 routes, right? I can either use the brick, which will end with 2 bricks and two ladders. And we see this state for 12, how far I can go. Or I end up with 10 bricks and 1 ladder, and I go to 12 and see how far I can go. So basically, let's do this one more time. So at a 19, that's going to 8. If you reach 19, it doesn't matter, right? If you reach 3, doesn't matter. You can only reach 7. When you reach 20, doesn't matter, right? You reach 7. So if you can reach 20, that means you can go to 3. Now at 18. So at 18, it depends, and we have 2 situations, right? So one situation is 0 ladder, and so let's redo this. So we are at 18 right now, right? So we're at 18. So at 18, we're gonna have, if you have 0 ladder and smaller than 2, the smaller equal to 1 bricks, then you're gonna, the maximum you can reach is 6. Otherwise, which means you have larger equal to 1 ladder or larger equal to 2 bricks, then you're gonna go to 7. Right? So that's this. Now we go to 3, right? Go to 3. We have to extend. Because that's like when you enter 18, right? When you enter 18, I say when you enter 18, you have 2 type of scenarios. So either you have 0 ladder and smaller equal to 1, and then we want to see how do we end up there. So we go to 3, and then 3 to 18, we have 15 difference, right? Now 15 difference cannot be covered by bricks. So if we want to make the journey, it has to be, so at 3, right? At 3, we know at 3, because I come to 8, like at 8, I say I have 2 scenarios. So at 3, would extend back the 2 scenarios will be, if you at 18 you have 0 ladder. Yeah, because on 3 to 18, there's only one way, that's use the ladder, which means at 3, you're going to have 1 ladder and smaller or equal to 1 bricks, or you have larger or equal to 2 ladders, or yeah, you can only have larger or equal to 2 ladders. So you must have either one ladder or smaller than 1 bricks, or you have larger equal to 2 ladders, and doesn't matter your bricks, right? Doesn't matter your bricks. And they have like tons of different combinations in this. I don't think that's correct. You have tons of different combinations. We're gonna fill this table. All right, this table is gonna take 10 to the 5th times 10 to the 6th. I'm not gonna fill the table. To fill the table is all types of situations. Yeah, there's heights dot length. It can't do that. Cannot do that. But I do think it has to be solved from the bottom up, because they don't have any conditions, right? So the problem now is 18 to 20. We kind of consider what type of situations will happen that can make me go from 18 to 20. So I say if I have larger than 1 or larger than 2 bricks, I can go from 18 to 20. So that's the 2 scenarios, right? That's actually has 3 scenarios for that. Or larger than 2 bricks. So yeah, that's the 2 scenarios. That's the 3 scenarios, right? So 3 scenarios. Now we're at 3, right? We say from 3 to 18. The only way to go is to use a ladder, right? The only way to go is to use a ladder. And I want to extend backwards, right? Extend backwards. So from 18 moving on, I have 3 scenarios. And then from 3 to 18, there's only one way to go, or there's no way to go, right? So we know the no way to go, if we have 0 ladder, then there's no way to go. But if we have ladder, right? If we have 1 ladder, if I have 1 ladder, right? And then we can just extend back, right? From 18, extend back. So 18 extend back is 1. So have at 1 ladder. So 1 ladder and smaller or equal to 1 brick, I will reach 6. If I have larger or equal to 2 ladders, I will reach 7. And if I have 1 ladder and larger or equal to 2 bricks, I will also reach the 7. Right? Yes. Okay, so that's that situation. To 3. Now we go a step back. Look at 7. Well, 7 doesn't. So 7 will be a repeat. So 7 will be a repeat. So this 7 will be a repeat situation as 3. Because 7 to 3 doesn't cost anything. Now from 2 to 7. So 7 we have 4 situations. Right? 7 we have 4 situations. Now from 2 to 7, what we have is, if we have no ladder and smaller or equal to 5, smaller than 5, smaller or equal to 4 bricks. We need to standardize it. Every time small, it's going to be smaller or larger or equal to. Right? Every time small, it's going to be smaller, larger will be larger or equal to. Okay. So smaller than 5. But smaller than 5 bricks, then I'm going to stay at 2. 0, 1, 2. So that's going to stay at 2. Right? Now, otherwise, then we can move. Now, how can we move? We can either use a ladder or we can use 5 bricks. So we go backwards. From 7, go back to 2. From 7, go back to 2, what we have is, if we have one ladder, right? If we have one ladder, we only have one ladder, then we are going to end up at 5, right? If we have 2 ladders, this is we're just adding ladder, right? For 2 ladders and smaller than 2 bricks, we're gonna go to 6. If we have 1 ladder and larger equal to 2, no, we have this larger equal to 3 ladders, we're gonna go to 7. And we have 2 ladders and larger equal to 2 bricks, we're gonna go to 7 as well. And then we'll consider the bricks, right? So 2 to 7, 5 bricks. So I'm gonna say 5 bricks. If I have 5 bricks, if I have 0 ladder, like we go 5 bricks. So if we have 0 ladder, right, and 5 bricks, then that will get us also to 5. And next one is if we have 1 ladder and smaller than 7 bricks, that will get us to 6. Alright? And then if we have larger or equal to 2 ladders and 5 bricks, that will get us to 7. And if we have 1 ladder and larger or equal to 7 bricks, that will get us to 7 as well. So 0 ladder and smaller than 5, right? And then we have 0 ladder and 5. And we have 1 ladder, that's also to 5. 2 ladders smaller than 2. We have larger than 2 ladders and 5 bricks. How do we combine these together? It's like larger than 2 and 1 ladder, which means just larger than 2 ladders. 1 ladder or 2 bricks and 2 bricks. 1 ladder and 2 bricks go to 7, and 2 ladders also go to 7. So what does that mean? That means if we have, we cannot combine, it's 1 ladder or 2 bricks. Then the combinations is exploding every time it multiplied by 2. And multiply by 2, so 2 to the n. All right, the condition, because each condition is multiplied by 2, unless we can combine them together. So 1 ladder can go to 5. 2 ladders and smaller than 2 bricks can go to 6. And larger than 3 ladders can go to 7. 2 ladders and larger than 2 bricks can go to 7. 5 bricks can go to 5. 1 ladder and smaller than 7 bricks can go to 6. And 2 ladders and 5 bricks can go to 7. And then next one 12, so it follows the exact same, and next one 4. 4 is 8 difference. Right? So we can add 8, which means if I have 0 letter or smaller than 8, then we're gonna stuck in 1. If we have, we can always just take a look at the maximum, which is 7, right? So 7. We have larger than 3 letters, we'll go to 7, which means at this point, if we want to, we only have 2 letters. We only have 2 letters, so that's the constraint, which means 2 letters, we'll go to 7. 1 letter and 2 to 10, right? 2 to 10 bricks, we go to 7. Oh, this might actually restrict some stuff. So it's actually 0 to 4 if I use this, right? 0 and 0 to 4. And then 1, we'll go to 5, 2, and we can call 0 to 1, right? So this is 0 to 1. And then 2 letters, we need to add one more letter, that's 3 letters. That's impossible. So this one is actually not possible. And then 2 letters and 2 to 10 bricks, right? 2 letters and 2 to 10 bricks will go to 7. And now we're gonna add bricks, right? Add bricks, so it's gonna be 0 letter and 5 bricks. Yeah, 5 bricks. 0 to 5 bricks, we'll go to 5. And then 1 letter and 5. So 0, 1 plus 5. The 5 is 6. Right? That's because we need to add 5 bricks. It's from 2 to 7, right? I have to add 5 bricks. 5 bricks will be 5 to 6, right? So 5 to 6. Then you go to 6. And the next one, if we have 2 letters and 5 bricks, you go to 7. Or you have 1 letter and 7 to 10, right? 1 letter, 7 to 10 bricks. You also go to 7. And then we simply just check the conditions of going to 7. Right? We just check the condition to go to 7. And then coming back, 12, we don't have to consider. 4, we have 8 bricks or 1 letter. Right? So 2 letters and that's not going to happen. Next one is 2 letters and 5. That's not going to happen. Next one, 1 letter, 7 to 10. That's going to happen because we can add 1 letter. So that's it. That's why it's 7. So I think what I need to keep a structure. So it's going to be a priority queue, right? And the priority queue and the conditions will just be values, right? Values. So like 2 letters will just be 2 to 2, right? It'll be 2 to 2. And then you're just going to add values to it. And if we cannot add a value, and that condition just not going to be carried on from reverse to the front. All right, so let's give another test on this one, see how this one works. So again, we're going to start from the bottom. 14, 3, 19, and 3. So at 3, that's the last one, always going to 0, 1, 2, 3, go to 3. 19, can always go to 3. 3, well, we have 16, so the conditions on this is the condition on this is we need 16 or 1. So if we have 0, 0 on letter, and 0 to 15 on bricks. Then we're gonna stuck at 1. Right? That's gonna be 1. Next, if we have we only have 0 ladders, so that's the only thing we can consider. We always like consider ladder, and then we say, oh, ladder, we cannot consider ladder, so we don't do ladder. And now we consider bricks. So if we have 16 to 17 bricks, but 0, 0 ladder, 16, 17, that will get us to 3. We can go on, right? And then go 14. 14 will always go to 3. I'm not completely sure, but I think it's worth a shot. It's already 40 minutes in. Not even sure about this. And I just typed something wrong. Should copy in first. And then it's T7. I'm gonna get water. Yeah, basically I'm just, going backwards. What the hell is this? This is not right. Oh no. What did I just do? Why is 20? Oh, it's 26. I kept doing 27. My mistake. And my water tastes terrible. A weird taste to it. Should have let the water run, for the tap water run a little bit longer before I start. Alright, just give it a shot. If this one doesn't work, we're going to check the hints. Okay. So, we're going to work backwards, right? When I have a priority queue, let's just import P. What's priority queue in Python? PQ? I forgot. Where's the documentation? Heap queue. Import heap queue. Right? So this is gonna just be options. Right? Options equals this. Now, we're gonna start from the last one, which means this one's going to be what's the last one? Len heights -1. That's the last one, but we want it has to be negative, and we're gonna do this and this. This will be from 0 to bricks. No, we'll go ladders first, and then this is 0 to bricks. Right? So that's the condition on the last one, which means that the last one, we don't care what you have. We can always reach there. Now we go 1 back. Now we have to care. So we're going to say for h in for I in range, going to be len heights. Oh, len height, use it twice. Let's put it out. Len heights. This len height is going to be n. So it's actually going to be -n plus 1. Because, yeah, it's n minus 1. And this is going to be range n -1, -1, -1, right? Now, what I want to see is the difference. So diff equals heights I plus 1 minus heights I, right? And we say if diff is larger than 0, because if it's the same, that's fine. If diff is larger than 0, that means I have to climb, right? Then we need to kind of compute what is the current option. We have to go through all of them. We have to go through all of them, right? Well, yeah, we have to go through all of them because it is possible at a certain point, yeah, we have to go through all of them, which means we don't go to -1, we go to 0 because the last one is we don't have to go through. Nah, that's fine. We'll just add another check. I will just add another check. So now we're going to go through all of them. So for this in range, how do we do that? I mean, we can just change each one of them and then heapify it at the end. Yeah, we do that and we just, if you want to pop it out and we see it's not good, just don't push it back in. If it's good, we push it back in. But if we push it back in, we're going to push into a new thing. That's what we need, a new thing. Yes, a new thing. So we need a temp, right? Temp is going to be this. So we're going to say while options, right? While options. And then op equals heap q dot heap pop options, right? I'm going to pop the option out, which is the largest at the moment. And then we're going to say what do we say? We say while options op pop it out, and then we want to check the diff, right? So we either go, oh yeah, and we also have there's actually a lot going on right now. So we're gonna say try try both, right? Every time we pop it out, we try both, and we say we can always, okay, hold on, so we have a range on the ladders, right? And we need to add 1. So basically, we're going to say try to add ladder. Try add ladder, right? And say if, okay, op, we have to say building, the building we can reach, and then ladder, ladder range, say ladder range and brick range, right? So that's a pop out. We say if ladder range is already large or equal to ladders, right? If it's already large or equal to ladders, then we don't do anything. We only add it if it's smaller than ladders, right? And actually, it's 0. If it's 0 is smaller than ladders, then we can say heap q dot heap push temp, right? And then we're going to push in building, right? And then oof. don't want to change it. That's the thing. I don't want to change it. So if you don't want to change it, what you should do is, let's say Lmin. Yeah, let's do it this way. Lmin, Lmax, right? And this is going to be Bmin, Bmax, right? Bmin, Bmax. And then I just say if Lmin is smaller than ladders, then we're going to push in Lmin plus 1. So you have one ladder to reach it, and Lmax, right? Lmax doesn't change, and then Bmin, Bmax doesn't change as well. Yep, so that's going to push it this. And then next one will be try add bricks, right? I'm going to say if and the bricks has, if diff is smaller or equal to bricks and Lmin is smaller. Hold on. It's not Lmin is smaller. It's Lmin plus diff, right? Plus diff is smaller or equal to bricks. No. If diff is smaller than bricks, right? If the diff is bigger than bricks, then there's no way you can go, no matter what. But that actually is contained in this, all right? It's contained in this. So we just need to do Lmin plus the diff. If it's smaller than bricks, then we can use bricks, right? I'm going to say try use bricks. Try use ladder. Try use bricks. So heap q dot heap push. So we can go temp, right? Same thing. We can go to the building, and then no change on the ladder, right? Ten, 7 to 10. Zero to 1 brick. Hold on, why I say 0 to 1 brick? What if I have more bricks? Well, at the end is like anything. I have a full range. And then we're going back. We're going to add. Let's make this add. So we have this to this. I'm not sure because I see a 0 to 1 and I don't understand now. Because I say 0 ladder from, I think it's from 9 to 14, right? 9 to 14, I say if I have 1 ladder. No, it's 14 to 12. No, it's, which one are you talking about? Oh, this one. I think it's 3 to 19. No, that's not 3 to 19. 3 to 19 have 17 in between, 16 in between. No. that's 18. I'm talking about 18 to 20, right? 18 to 20. And what we say 18 to 20 is 18 to 20 is if you have two, like 18 to 20, right? The difference is 2. Right, the difference is 2. So an L min is 0, right? L min is 0. So we can do 1 to 2 on a ladder, right? So 1 to 2 on the ladder, and then doesn't matter, 0 to 10 on the bricks. Like any one of them will work. Like we're talking about range, right? We're talking about the range. And then we can also add bricks. So we say it has to be 2 to 10 bricks, and 0 to. I think this is actually different from what I thought before, so therefore I need to re-examine and see if this one works still. So from 18, now we say we can reach 7, right? We can reach 7 with 1 to 2 ladders, or 0 to 10 bricks. Or we can reach 7 if we have 0 to 2 ladders. We don't care about ladders. Or we have how many? Have 2 to 10 bricks, right? Have 2 to 10 bricks. So that's from 18 to 20. Now go from 3 to 18. Now also, if we stuck at 6, we need so 0 ladders and 0 to 1 brick, right? So that was stuck at 6. Now going to 3, we have 15, right? 15 bricks, and then we have 15 bricks. So, but we can have the ladder, which means everyone gonna do ladder. So 2 to 2 ladder, 0 to 10. 7 will be 1 to 2 ladder, 2 to 10. And it will be 6 will be 0 1 to 1. Right? 1 to 1, because we add 1 to 1, and 0 to 1. That one will be this. Okay. And also, that's just adding a ladder. Now, we cannot do this because it's always going to not work. So, and also we want to stuck at 3, right? We want to stuck here. To stuck here, all we need is a 5. We have 0, 0, no ladder, or 15, 0 to 10, right? Basically, no ladder and 0 to 10 bricks. Then we're gonna stuck. And then we go back. We'll go to 7, 7 to 5, go to 2, right? Go to 2. Go to 2. Again, we can go ladder, but we cannot do the first one. But we can do the second one. So we have 7, 2 to 2. Let's go with ladder. Right? Let's go with ladder. Or we can reach 6, give us 2 to 2, 0, 1. Or we can reach 5, give us 1, 1, and 0, 10. That's using ladder. Now we can also using bricks. We need 5 bricks. 5 bricks we can do 7, 2, 2, 5, 10, right? Or 7, 1, 2, 7, 10, 6, 1, 1, 5, 10. The last one will be 5, 0, 0, and 5, 10, right? And also on a stuck at 2, to stuck at number 2, we will go to stuck at 0, 1, 2. I think I got something wrong. I got something wrong. I don't think it's 0, 1, 0, 1, 2, 3, 4. Yeah, that's actually a 4. Yeah, that's a 4. So that's actually a 4. It's not a 5. That's a 4. And now, that's 7, right? No, that's 3. That's 4. 0, 1, 2, 3, 4. 3 to 7. We don't have to consider. That was a 2, right? 2. It's still a 2. No ladder. And 0 to 4. Right? 0 to 4 brick was the 2. 12 we don't consider. Now we'll go 4. At the beginning, right? At the very beginning. At the very beginning, when you see, we need 8. 8 bricks. Oh, the first one works. 8 bricks. That's it. And 8 bricks. Yeah, 8 bricks or 1 ladder. We can go both ways. So yes, I think this one does work. Does work. Okay, so we go through this. We're gonna do this, Lmin. We can use ladder. This is we can use bricks. Actually, this has to be max. No, min. Lmax and Lmax plus 1. I mean, of course. Plus 1. No, that's not Lmax. That's just ladders. Alright, we need to separate this like this. Otherwise, I don't even know what's going on. So we have this, we have this, we have this. We have this is this. There we go. Yes, here's the same thing with the main value. Bricks. Actually, it's not mean value. It's because we always an add, right? It should be just and plus 1, right? It should be just Lmax plus 1 and yeah, that's fine. That's fine. Just like it cannot be larger. It cannot be larger than ladder. That's basically what it means, right? It cannot be larger than ladders. Okay, and here we're going to follow the same suit, right? I'm going to follow the same suit. So building doesn't change. This doesn't change. Now this will change. It's going to be, it's not Lmin, bmin, right? So it's going to be bmin plus diff, right? Bmin plus diff, and then the main value of bricks and bmax plus diff, right? Here. Okay, so after these two, now we're going to add while options. So we're going to take all the option, pop it out, and push it in if we can. If we cannot, then we don't push it in. And then at the end, we're going to push in one more thing, heap q dot heap push. One more thing, it's going to be temp. That's the current level, which means it's I, right? Minus I, current level. And which means we got stuck, right? We stuck at the current level. How do we get stuck at the current level? We have no ladder, right? And we have no ladder, and we have smaller than the, so we have 0 to diff minus 1. Smaller, so 0 to diff minus 1 number of bricks, right? So we also added in there. So we go through everything, right? We go through everything. Actually, I do think we go to 0 and I'll push the temp, push it one more time. After we push this, we get out, options equals temp. Now we go back up, right? Go back up. We, for the next one, find a diff. If it's larger than 0, we do this. If it's not, we just keep going. And then we have temp, just kind of compute all the options. And when this loop is finished, right? When it's finished, what is happening is, oh my god, this is just such a sore in my eye. I don't care. It's just too ugly, man. It's too ugly if I do it the other way. I cannot stand it. Sorry. Simply cannot stand this to be multiple lines. Yeah, I'll just do it this way. When we get out, now we are at the first level. So we say diff equals heights I is 0, yeah, plus 1 minus heights I, right? So we say now what do we say? We say if diff is larger than 0, if diff is smaller or equal to 0, then when we return options.pop, no, heap queue dot heap pop options, right? And then return the first one. Well, it has to be minus. Else, then we're going to say while options. We'll do this, right? And we say, what do we say? We say if L min is smaller than letters, right? L min is smaller than letters, then we return minus BD. If B min plus diff is smaller or equal to bricks. Okay, these two can be combined, or yeah, combine. If this, then we return. If not, we have to keep going until we find out one that satisfies. Which I do think we don't need this. We just pop the first one, because if diff is smaller than 0, then this one will definitely smaller than bricks. So it's going to be like this, right? And then this is to treat the first height. Find the return the answer. Return the answer from the perspective of the first building. Right? Now we're gonna test. How do we test? We have heights, we have bricks, and we have ladders. Heights, bricks, ladders. This one can be 4. Alright, the second one is this. 10 bricks and 2 ladders. Give us 7. Oh man. All the way down. Good. Next one, we have this. Then 17 and 0. right? 17 and 0 give us 3. I'm kind of feeling this might time out. I'm not confident at all. No, not confident at all. Bricks. What else? Ladders. Ladders. Then this is furthest the building. We'll go heights, bricks, ladders. Take a look. Invalid syntax. Forgot this. List out of range, and we don't have diff. Where? List out of range. Huh. Oh, n-2. We passed the first one, we failed the second one, and then we passed the third one. Alright, problem with the second one. Let's take a look. Second one, I think what I'm going to do is at the end of each one, we're going to print out, right? We're going to print I, print I, heights I, I don't need heights I, just I, and options, right? Okay, so we are at 7. Let's see if we can. Okay, that's the best I can do. So we're at 0, 1, 2, 3, 4, 5, 6, 7. Okay, we first at here. Can go to this position if we have 1 to 2 letters, right? If we have 1 to 2 letters and 0 to 10 bricks, that's true. Or we can stuck here if we have 0 to 15, that's right. Now we go to this one. Now this shall be exactly the same because I didn't change anything. Yeah. Now I come to 18, which is here. So we can have 2 and 2, right? I think that's the same as what I'm saying. Oh, -8. Ah, I see the problem. I see the problem. If diff logging is 0, and then option, right? Option is last option is -8. And then do that, and then coming in. Yeah, this is not happening. It cannot reach -8. Cannot reach -8 because why it cannot reach -8 again? You can. 3 to 19, you can. You just add a letter. So you can reach -8. Right? You can. But the thing is, at 1, I have -8, 2, 2, 7, 10. -7, 2, 2, 2, 10. Which means it's fine. I can use this. So a pop out, or let's say pop out, so it's going to be -8, 2, 2. So if 2 is smaller or equal to letters, smaller or equal to letters. No, that's smaller than letters. Right? Yeah. That's still not right. Or then 7 plus 8 is 15. Okay. Yeah, 3 can get to 19. How you say 3 cannot get to 19? You just have a letter, right? You just need to have a letter. From number 7 position, you can go to 8 if you have a letter. So 1 to 2 letters, right? And then you get stuck, right? And then you go 20, 20 is the same. You got 18. 18 will be you have 2 bricks, 2 to 10 bricks, yeah. Or you have 2 and 2 on the ladder, yeah. Or a minus 7, 1 and 1 on the ladder, yeah. 2, yeah. And minus 5, yeah. No ladder, but you have plus, you have 1. 1, 0 to 1 brick, right? Now go to 3. For the 3, we can do 3 to 18. We can use 1 plus 1 ladder, right? And we want to say 3 to 18 have 15. 15 difference. I cannot do. Okay. So here, cannot do 15. Cannot do. We only have 10. All right. Yeah, this cannot do because maximum is 10. Maximum is 10. And B min is 7. 7 plus diff. Diff is 8. That's 15. That's not smaller than the bricks. Hold on. From the last one, at a 0, and take a look at the options. Yeah, 0 options here. 8 cannot reach. Pop it out. 2 and 2. 2 smaller than ladder? No. Or B min. B min is 7 plus diff. Right? What's your diff? Last diff minus 10. What? What? Heights? Huh? Hold on. Something is very wrong. How is the diff range? Oh, it doesn't. I didn't go to. I know. I didn't go to 0. There we go. Now we pass. This is just I forgot it's a for loop. For loop is different. For loop, the I does not take the last value. Okay. That's some time wasted. Try it. Judging. I'm sensing a timeout. Oh man. Alright, I'm gonna check the results. Oh, it's a wrong answer. I thought it's a timeout. It could be timeout. I passed 10 cases. 1, 2. 1, 2, 0, 0. We should expect a 0. We got a none. That is interesting. That's the edge case. I don't think I tested any edge cases. I need to test edge cases. I want to test more edge cases. So 1, 2, 0, 0. What's happening in 1, 2? Well, what happens is that's 2. That's minus 1, right? Then 0, 0, 0, 0. And goes in. Oh, it does not go in. Right? It does not go in because n equals 2. So it does not go in. Come here. Height, that's diff is 1. All options. I do have something in the option. So BD come out. And when, oh, it's the option doesn't work. Right? Option doesn't work. What do we return? Option doesn't work. Like if at this position, it doesn't return. So none of the options return. So I can only, this is going to be return 0. Yeah, we need to add a return 0 at the end. And we also going to test, I don't know, I'm not sure. Yeah, that shall work because we will have this will not run. Oh, that's have a runtime error because there's no height 1. I think that's just edge case. If n equals 1, it's going to return 0, right? If n equals 1, we just return 0. That's just the edge case. Yeah, okay, try it again. Pending, judging. I still feel like it's going to time out. If it times out, I'm going to check this hint. It's really late. Time limit. Yeah, it times out. Okay. Oh, I only go with 11 cases. Oh my god, this actually is a very bad solution. Very, very bad solution. TLE. Okay, can we improve on this? I mean, if we print it out, the result, we will see it is pretty bad. Like, it's like if you print it out, you will see it's pretty bad. It's like getting really long. Let's see if we can maybe we can combine some of the cases together to make sure it doesn't grow too much. Let's try print I and options, right? But take a look at here. -6 and -6. Can these two be combined? Yeah, because we say 0, 1, 5, 5, we're good. 1, 1, 0, 5, we're good. So I can say 0, 1 to 0, 5 is good. Actually, no, 0, 1 and 0, 5 is not good because if it's 0, 1 and like I have 0 ladder, but I have 4. Right? We're talking about this difference. 0 ladder and 4, then I cannot go. It has to be 5, 5. And I lose some, I get some. How about these two? These two can combine. 1, 1, 3, 5, and 1, 1, 5, 5. It can combine into 1, 1, 3, 5. 1, 1, 0, 4, 0, 0, 3, 5. 1, 1, 0, 0. They can combine, become 0, 1. So if it's a 1, 1, we need it to be 0, 4. right? 1, 1 can be 0, 4. And if I don't 0, 0 can be 3, 5, right? So what it is saying is, so 1, 1, if I have 1, I can take 0 to 4. But basically, yeah, when I take 0 to 4, I can reach 4. Or if I have 0, 0, I can take 3 to 5, right? Which means if I have 0, it must be 3 to 5. If I have 1, it can be 0 to 4. Can I say 0 to 5? No, I cannot say 0 to 5 because it has to be 3 to 5 if it's 0. And if it's 1, it can get relaxed. And then the overlap, so tell me to say 0 to 1. But, all right, let's take a look at the hint. What are you doing, man? Take a look at the hint. Hint 1, whether you can reach the last building or not. You will have to do a set of jumps and choose for each one whether to do it using a rope in the largest jump. Okay. Iterate on the buildings, making the largest jumps and the sum of the remaining ones so far, and start whenever the sum exceeds b. You would choose either to use a rope or a brick. Yes. Right? So it's like either I take me or you don't take me, right? So either I use rope or I don't use, either I use another rope, it's a ladder. Either use a ladder or we don't use a ladder, but you use bricks. And then we always want them to keep moving, so whether you can reach the last building or not. It's always optimal to use ropes in the largest jumps. Iterate on the buildings, maintain the largest jumps, and the sum of the remaining ones so far. Sum of the remaining ones, the remaining jumps, and stop whenever the sum exceeds b, whenever the sum of the remaining jumps is larger than b. Maintaining the largest jumps. Why these hints never make any sense to me? They say iterate on the buildings, maintaining the largest R jumps. What's R? And the sum of the remaining ones, remaining jumps, and stop whenever the sum exceeds b, which means you cannot move forward. Okay, this one TLE means it's correct, but I don't understand. So for each one, either jump, not jump, we either brick or rope or ladder, right? Either brick or ladder. Counting the jumps. The largest jump. So we're either using a rope, a ladder, or position, we're either using a ladder, right? So if we use a ladder, or we use bricks. If we use ladder, then well, we bifurcate. I'm gonna read whether you can reach the last building or not. Okay, do a set of jumps. What do you mean a set of jumps? And choose for each one whether to do it using a rope or a brick. It's always optimal to use rope and largest jumps. The largest jump. Iterate on the building, maintaining the largest R jumps. I mean the jump, I mean like jump high, like jump up. And the sum of the remaining ones so far. I don't understand. The largest one, the largest jump. I mean, the largest jump needs to be coped with the ladder. And the sum of the remaining ones. Sum of, yes, actually that does make sense because I know I can see to the end. So I can compute the total number of climbs I need to do, right? The total number of climbs I need to do. For instance, for this test example, total number of climbs is, 4 to 2 is no climb. 2 to 7 we have 5, right? 2 to 7 climb 5. 7 to 6 no climb. 6 to 9 climb 3. 9 to 14 climbs 5. 14 to 12 no climb. So the total number of climb is 13, right? So this one, the total number of climb is 13. To reach the end is 13. And we actually can compute the total number of climb to reach each one, right? So I used up one of my paper. So the total number of climbs to reach, again, do it again. I have 4, 2, 7, 6, 9, 14, and 12. So the total number of climbs you need to do is 4 to 2 as 0, right? And then 5, 5, 8, 8 plus 5, 13. Did I say 13 last time? Yeah, 13 and 13, right? So that's the number of we have to climb. So we check it's 13. It's larger than what we are allowed, right? Larger than what we are allowed. So we have to use some ingenuity, and then we also know among these, right? The biggest jump is 5, right? The biggest jump is 5. So we go 4 to 2, 2 to 7, we have a 5. So we record here 2 to 7, we have a 5. And then 7 to 6, and 6 to 9, I have a 3. So currently 5 is still the biggest. And 9 to 14, we have a 5, right? And then, so we know that a ladder has to be used either in one of the 5s, right? So one of the 5s has to be used, and the ladder. And it doesn't matter, always use it, because use at the front, use at the end. If we do not use at the front, then we might get blocked. So we use at the front to use ladder, and then so what? So you have to go through it. Oh, I think what it means is you just go through it go through it once, right? Once, and then you can determine where you use the ladder. You go through it once, then you know where to use the ladder. And once you fix the ladder, now you have a 3, which can bring you to 0, 1, 2, 3, 4, bring you to 4, and then we have a 5, another 5, which will bring you to 7. 0, 1, 2, 3, 4, 5, bring you to 5, right? So, and now you have 5 remaining, and you just check. 5 minus 3. Well, it's actually, it's going to be 8. It's going to be 8 will bring you to 5. And then, so you just count. Actually, we just do to 5. And 5 is 3, 3 cannot go, so the most you can go is 4. Okay, let's try this one. Oh, the hint does work. It takes care of all the ladders, so you don't have to worry about ladders at all. So we have 4 to 12, right? 4 to 12, which is what, 8? 8 jump can bring you to 2, and it can bring you to 1. And then 1 to 0, 1 to 3. A 5 jump bring you to 3. So 5, 15 jump bring you to 5. 2 jump bring you to 7. No, 0, 1, 2, 3, 4, 5, 6, 6, 6. And then 16 jump bring you to 8. All right, so that's, we can read through, and then we fix on the ladder. We have 2 ladders, so you say we can do the 2 biggest one. But the biggest one is 16. That's at the end. How do you determine? All right? How do you determine? I mean, you also have to add them together, right? So we have 1, 4, 9, 15, and 23, right? And we have 10 bricks. We have 10 bricks. So, which means use the brick all by itself, we can reach 9, or we can reach level 5, right? Use the bricks by itself. Now we just want to know how can we extend it by using ladders. So we just see, yeah, so we keep using the bricks until we cannot anymore. Then we swap in using the ladder to remove the block. So the largest one is 5. So we're going to use ladder for 5. So now we used, instead of 9, we used not have 1 left, right? We have 1 left. Okay, now go. So we take away 5. Now we have 6, right? And then we still cannot go, right? We have 6. We still cannot go. So we take another one out. Now we have, no, wait, hold on. We have 6, we can go. 6, we can go. Jesus, I got it wrong. That's the position. I got position and then the other thing wrong. So we have 8, right? First is 8, so we go. We have 10, and we have 2 left. Right, 2 left. And then boom, we had a 5. We're like, we cannot go. So we swapped first with a ladder. Now we have 10, and we can do 5. So we have 5 left. Next one is 15. 5 we cannot go. So what? So we swap the 5. No. Oh man. Oh man. Oh man. Still, like, when do we use the ladder? Well, we use the ladder on the biggest one that we see so far. That's when we use the ladder, right? Because it's always I just assume I'm gonna use bricks, right? Assume I'm gonna use bricks. So I use bricks for the first one, and I cannot go to the second one, right? Because they're plus together, that's 13. I cannot do it. So in order to move forward, I have to take away 8, right? Take away 8. So if I take away 8, now I have 10, right? Now I have 10, and then we can handle 5, which gives us 5 left. Now we have to handle 15. 5, I cannot handle 15, which means we have to go, we have from 5 and 15, we'll pick a bigger one, right? So just up until now, the biggest. Up until now, the biggest is 15. So we swap 15. We don't use 15. Now we can go forward. We still have 5. Now next one is 2, which is fine. And we have 3 left. I think that's what it means. Now I think I know what it means by maintaining the largest R jumps. So you just keep going, and then you do jump, you climb, and you climb, always climbing, and until you cannot climb anymore, right? And then on this sequence, right? On this sequence, you basically cannot accomplish by just using bricks. So, therefore, there must be one that you have to use the ladder. Now you always use the ladder on the largest one of so far. Yes, this works. This works. Absolutely, this works. Now the hint takes a while to understand, but it's working. It's working. All right, so this is from the hint, right? So here's what happens. We just going to iterate through, and then we're gonna say max climb, max diff 0, right? So I'm gonna say for I in range to land heights -1, right? And then I actually don't like it. I actually do like it. So I'm gonna say what do we say? Current diff equals heights I plus 1 minus heights I, right? And we say if current diff is smaller to bricks, smaller to bricks, right? If current diff is smaller to bricks, bricks minus equals current diff. Else, current is larger, okay, we cannot do. And then we say, so current diff is this, and then we update max diff as well. Max diff equals max diff current diff, right? Yes. And they all happen if current diff is larger to 0, right? So current diff is smaller than, actually it doesn't matter because max diff will be 0. No, yeah. Else current diff is larger. That's actually I can do equal. That's fine, right? That's equal. That's fine. If it's not, which means I cannot handle, the bricks cannot handle anymore, then when it just use the max diff so far, right? So what we're gonna do is ladders minus equal 1? It has to be aleph. Aleph ladders is larger than 0. Then we use a ladder, and we're gonna bring it back. Bricks plus equal to to max diff, right? And when we give it back, the max diff has to change. It has to change. Change to what? So we need two values, the max diff and then the second biggest. Is there a way for you to do this? Yes, something called priority queue. Because after you take away 15, right, and then the next biggest one, hold on, do we restart? Like we hit here, we cannot move anymore, we plug the biggest one out, and then we supply the bricks back in, and then try to move forward, and then we cannot do it again. And we're gonna do, yeah, I think I do need, the max diff is going to be this. Max diff is going to be this, and we're just going to do heap queue dot heap push max diff and minus current diff, right? So we just, every time we push in, and then if it's this, it's fine. If it's not, and the ladders, we have ladder, then we say ladders minus 1 equals 1, right? So ladders and bricks can equal to heap queue dot heap pop max diff, right? Max diff. It's actually not max diff, it's just all the diff, right? It's all the diff, and it has to be minus, right? So bricks turn it back, and then keep going. Right, keep going. When do we stop? Well, if this doesn't work, and this doesn't work, which means current diff is larger than brick, cannot go on, this cannot go on, and this is when we stop. Return I, so we cannot move on. Right? And at the end, if I go through everything and I still never hit this, and I go through everything, which means I'm standing at I, right? And from I, I'm trying to see if I can go to I plus 1. And if I do all these, that means I can go to I plus 1. Right? I can go to I plus 1. So when we out, we can just return I plus 1. Okay, that's the second solution. It's not correct. 0, 1, 2, 3, 4, 5, 6. Muy interesante. Shouldn't we, right, so diff, right, smaller, keep going, 5 I can handle, right, 5 I can handle, bricks becomes 0. This I can handle, 0, 1, 2, 3. And then, now in here, we have 3, but when we have 0, current is 3. Right, current is 3. Current is 3. 3 is smaller than the bricks. No, bricks is 0. And now ladder is 1. Good, so we can do ladder, and we're gonna bricks plus equal to 5. So 3, 5. Bricks become 5 again. 5 again. Oh, I still need to... Okay. So it should be if current is larger than brick, which means I cannot do, right? And ladder larger than 0, then we can do this. And after we do this, no. We have to do this again, which means bricks is equals bricks minus this, yeah, and minus current diff. Oh. It has to minus 3, right? Minus 3. Then move some here, right, on I, and keep going. Come to 4. 0, 1, 2, 3, 4. And then the diff is 5, but I have only 2 left. So current diff is larger than bricks. No, it's actually not larger. Why is it larger? It's smaller. There we go. Now we pass. And then we'll try the other ones. They all pass. Okay, that's the solution. From the hint, original one is timing out. This one shall go with the ON. There we go. That's the one. Alright, this is from the hint. The hint is a bit hard to understand, but it does make sense after some thought, right? So we start with this. As we are moving through buildings, we either use ladder or brick. Let's assume that we use only bricks and go as far as we can. When we get stuck, that means when we get stuck, we can unstuck ourselves by using ladder on one of the climb. The most efficient use of ladder in this situation is on the highest climb. Therefore, we keep track of the highest of all the climbs, right? Of all the climbs until we get stuck, and swap the highest climb with the ladder and replenish our bricks. We can use a priority queue to keep track of the highest climb so far. We continue doing this until we run out of ladder or do not have sufficient bricks. Yes, because can imagine it's just a sequence of ladders and bricks, right? A sequence of ladders and bricks, which means we can imagine we go all bricks and then we just swap some brick with ladders. And this will run O. ON is this, but we also have this, which is ON log n, because we also use the priority queue. I don't think there's another way, because you cannot just keep a max. Keep a max, you pop it out, then what? And then how do you find the max after you use the max, right? So that's that. Take a look at here. We hit 580 milliseconds, which give us 76% ranking. All right. It's a good question. I think it's a medium. Well, I mean, I find a solution, just times out. Yeah, it is. This is the correct solution. I think this is on the hard side. Coding is not that hard. It's just the thinking part. Okay. The difference. One. Push len heap larger than ladders. This is like keep pushing ladders. There's a keep pushing ladders. I'm keep pushing bricks. All these ladders and run out of ladders, and we use the smallest. Yeah, smallest will go to the brick. Yep. Greedy solution may be wrong. Oh, wow. Uh-huh. Use bricks for one move. Yep. Oh, okay. Good solution. Yeah. I mean, this is not even an end. This is a 2 to the end. Wow, it is pretty good, right? It's pretty good. I mean, it's the same idea. This problem can also be solved by always using ladders and then swap with bricks. Current if smaller than this, and then bricks. Else, right? So current diff is larger than bricks, then ladders -1, right? Ladders -1, and then so we use we swap with ladders, and then we need to update the brick as well. So brick minus the maximum brick current we have, and then also material minus the current difference. And after we do all that, and you check, say if the right, so brick, and then if the brick is smaller than 0, we check on ladder, right? We check on ladder. I mean, it's possible that even if brick, we add the maximum and it can still be smaller, right? So we just check, right? So let's just say we're gonna do an else here, right? And after we do this, then we're gonna check if ladders is smaller than 0, right? Or bricks smaller than 0. That means we cannot move to the next one. That means current one is the maximum we can reach. And yeah, I think this one's good. We cannot move to I plus 1. So I is the maximum we can reach. Okay. That's about it. All right, that's it. I mean, everything else is about the same. There's a binary search. Building number K. What gaps between them? Cover. The biggest L to them. Reach. Okay, we can all previous. Too long. Heaps. Taking heap, the L biggest the gaps we have so far each time when we have new powder together, put it to heap and extract one, smallest one. But to use bricks for this gap. I don't want to read it. Suddenly don't feel. I mean, this is sufficient. I'm gonna kind of ponder on it a little bit more. Just kind of think, how did I not get it? I think it's important. Like, what is the mind trick that allows you to figure out that solution? All right, that will be it for today. I will see you guys tomorrow. Adios.